This is lesson 9. We're on chapter 3, section 5, limits at infinity. We're following a book by Carson for calculus. Okay, we're learning about limits at infinity today. We're going to try to determine finite limits at infinity, determine the horizontal asymptotes at any of the graph of a function, determine infinite limits at infinity. Okay, limits at infinity are horizontal asymptotes. Okay, so this section discusses the end behavior of a function on an infinite interval. Consider the graph of f of x equals 3x squared over x squared plus 1. All right, so if you put that in your calculator, 3x squared over x squared plus 1, you hit graph, you'll see that it comes into 1, and then it almost makes a straight line then up there at the number 3. It comes really close to being 3, but it never crosses the 3. So 3 is a horizontal asymptote at y equal to 3. And it's coming down into 0, and then it comes back up. So if you looked at it numerically at the numbers, you see that they get close to 3 as they approach the number 3. And as they approach the negative numbers, they also get next to 3. So as it goes to infinity, it gets to 3, and it goes to negative infinity, it gets to 3. And the quick way to do limits, and I'll say it again, is you look at the highest power on the top and the highest power on the bottom. So the y asymptote is 3x squared over x squared. The x squareds cancel out, so it's just y equals 3. So that's the horizontal asymptote, and the limits in infinity to the left and the right are going to approach that. All right, so guidelines for finding limits at plus and minus infinity of rational functions. All right, so if the degree of the numerator is less than the degree of the denominator, then the limit of the rational function is 0. Okay, so the degree of the numerator is less. So the top of it, if it's less than the degree of the denominator, so I'll make it something bigger, then the limit of it's 0. So if it's much bigger down here than up there, well, if it's bigger, then you see things cancel out. So you'd have like 1 over x squared. So as it goes to infinity, it's still going to infinity. So 1 divided by infinity is 0. Next one, if the degree of the numerator is equal to the degree of the denominator, then the limit of the rational function is the ratio of the leading coefficients. So just like on that last one, the top was 3x squared and the bottom was x squared. So you cancel out the x's and it became 3, y equals 3. And that's y equals 0. And the next one, if the degree of the numerator is greater than the degree of the denominator, then the limit of the rational function does not exist. So if the numerator is greater than the denominator, then see when they cancel out, it's x to the third, and so it's going to infinity. So there is no horizontal asymptote at all. All right, so on number 18, we're supposed to find the limit as x approaches negative infinity. So we're allowed to split a limit up. So this is the same thing as the limit as x approaches negative infinity of 5 over x, and then minus the limit as x approaches negative infinity of x over 3. So when you put infinity into that, you get 0. And when you put infinity into that, you're going to get, well, you're putting negative infinity into it. So negative infinity divided by 3 is negative infinity, and negative make positive infinity. So the answer to the first one's positive infinity. Okay, and then the next one. Okay, to give you I'm going to give you the quick answer, then I'm going to show you the long answer. So again, the quick answer is you look at the highest power on the top and the bottom. So that's 4x squared over x squared, so that's what y equals. They cancel out, so y equals 4 is the horizontal asymptote for it. So as the graph goes to negative and positive infinity, the graph's approaching the number 4. The longer answer to it is you're supposed to take whatever the highest power is in the denominator and divide everything by it. The highest power in the denominator is x squared, so divide everything by x squared. And then you look at it as it goes to infinity. So here that's 4. 5 divided by infinity would be 0. That's the number 1. 3 divided by infinity, 0. So you get 4. So that's the longer answer, and that's, I don't know, some people might want you to write it out, the whole reason why. That's fine. You can do that if you want. And again, the key is you're supposed to divide by greatest power in the denominator. Well, greatest power of x in the denominator. All right, so on the next one, again, the quick answer is look at the powers that are the highest. That's the 3s, so it's 5x to the third over 10x to the third. So that makes it 5 over 10, or a half. A longer answer is the highest power in the denominator is a 3, so you're going to divide everything by x to the third. So that 0, that 0, that 0, and that makes 5, and that makes 10, so it's a half. I would agree it's easier just to look at the highest power. So we got x cubed over x squared, or just x. So as it goes to negative infinity on this one, the top was higher. So it's just going to go to negative infinity. It's not approaching a specific number. It's going to negative infinity because that's what we're plugging in. Down here on the next one, we have x over the square root of x squared. So the square root of x squared is just x. And we're going to negative infinity. So when we're taking that out, we got x over x, and we're going to negative infinity. So it ends up being a negative 1. Let me see. I wonder if it would help to explain why it's going to negative 1. Because when you take that out, it's got two answers. It's got plus or minus x. So, and because it's going to negative infinity, you've got x over x, or you've got x over negative x. So as it's going to negative infinity, that one's going to, well, x over x is just 1. It's probably best just look at the graph and you'll see that it's going to negative 1. So looking at it here, we have y equals x divided by, and then in parentheses, I don't think you need parentheses because it's in that square root. So square root of x squared. It doesn't hurt to use parentheses, but you don't always have to use them. So you can see that it's approaching negative 1 to the left, and it's approaching positive 1 to the right. Oh, that's interesting. All right, so the limit, well, so what was the question on it? I don't know, but so the horizontal, it's got two horizontal asymptotes. So the limit, as it goes to negative infinity, it was going to negative 1. As it goes to positive infinity, it's going to positive 1. So yeah, the answer to it is negative 1 as it goes to negative infinity. All right. On the next one, now this is going to positive infinity, so it's not as messy. The negative infinity one's a little messy. So this is 5x squared over x, which just makes 5x. So as it's going to positive infinity, that's going to infinity. And then on the next one, we have the square root of x to the fourth over x cubed. So that's x squared over x cubed, or 1 over x, and it's going to negative infinity. So it doesn't even matter, it's negative infinity, so it's 1 over infinity, and so that's going to be 0, whether it's positive or negative infinity, that makes 0. Then on 34, when you got 1 divided by infinity, that's 0. So we're really looking at the limit as x goes at infinity of the cosine of 0 is what it's going to be, and when cosine is 0, it's equal to 1. All right, I'll see you for the next lesson, and we're all done with chapter 1 now, so we're going to take a test.